Hello YouTube viewers, welcome to my show Future Friday. Today we're gonna take a look at the hydrogen economy, or specifically why did it fail. So let's dive right into it. So what is hydrogen? Hydrogen in simplest term is an element. It's very pure and it burns in the presence of oxygen. So like Earth's atmosphere, it can burn. And if you want to make it in a liquid, you have to cool it down to minus 252 degrees centigrade. Basically, it's almost as close to absolute zero that things can go. Only one thing exists that can go even colder than that, that is helium. And so suffice to say, to make hydrogen into liquid, which is used, as you can see, in rocket industry, it's quite expensive process to liquefy it. And the name hydrogen as we know it, there are a lot of people who discovered it, but the name that we have came from 1783, and gave him this guy. Basically, that time we didn't had camera, so we knew about hydrogen for quite some long time, but suffice to say, we have lot of industrial use for hydrogen even today. So why the interest in hydrogen economy come to the forefront in the first place? You have to understand, if you take 1 kg of hydrogen versus 1 kg, the weight, 1 kg of kerosene, hydrogen is like, don't even try to compare. Like, I'll give you a simpler example. All the engines, rocket engines, jet engine, they are measured in specific impulse. Higher the number, the more efficient it is. Not necessarily powerful, but more efficient, basically the mileage. So this graph, as you can see, depicts multiple engines that we have, and then this angle is the speed. It's specified in Mach speed, like Mach 1, Mach 2, Mach 3. So as you can see, there is a steep curve as you have different technology. Now there is a line, dotted line, that is depicting theoretical maximum of hydrocarbons. Like, this is theoretically maximum allowed by laws of physics. So this is here. Now this is what theoretical maximum of hydrogen is. So hydrogen has a lot of power if you compare it by its weight. And you have to understand, when you burn hydrogen, the benefit of that is the output. Basically, if you are burning hydrogen in your car, the output of that is water vapor. So suffice to say, we can't even create something that harmless. It's water, basically. It's gonna come out in vapor form, but suffice to say. And the reason we got a lot of early interest in fuel cell vehicles was because fuel cells make direct electricity. There is no burning hydrogen, then turning then getting rotational energy. We can just simply send hydrogen into fuel cell and get direct current out of it, basically DC electricity out of it. So this also sparked a lot of interest, because it was very efficient. Like, if you have the hydrogen, this is very efficient. Now, and it can be made on site with only 2 components. What do I mean by on site? Basically, instead of petrol pump where you're pumping the hydrogen, you can make the hydrogen right there. All you would need is power source and water. Suffice to say, wherever humans are, it's quite readily available. So it was possible to make hydrogen on site. So what's the problem? Like, all the things I showed you, they are proven, they are absolute, like they are scientifically true. There, nothing about it is like hoax or things like that. So one thing you have to understand, hydrogen is super low density. To give you a context how low density it is, if you fill it up in a balloon, it will go up. And we used to use that. The reason we no longer use that is simply because it's flammable and dangerous to have around kids. So we now use helium, but hydrogen is so light that it can carry its own mass and some body around it. And fuel cells, the whole idea is not cheap. Fuel cell, even to this day, never became as cheap as internal combustion engine, and their power to their cost is simply pointlessly expensive. Just no point when trying to compare it. And it acts more as an energy carrier. Now this is the thing that people are forgetting about hydrogen nowadays. It's not an energy source, it's an energy carrier. Hydrogen is not naturally available. Only some places will have some small pockets of hydrogen, but you can't dig hydrogen out of the ground. You have to put energy in. This is the same problem why you can't run your car on water. Hydrogen needs energy to make it. Like you will put electricity and water, then you will get hydrogen. Or you can mine it somewhere, but there is no place where you can mine it. Even though 90% of universe is made out of hydrogen, in this planet, it's not available in gaseous form, at least not easy to extract. And one thing you have to understand, the hydrogen, because of this low density, it's kind of frustrating to understand how bad the weight to the size ratio there is. So think of it this way: to get the maximum efficiency, either you have to make a liquid hydrogen, as you can see, which we do know how to make, but as I told you, it requires near absolute zeros. So it's suffice to say it's quite energy expensive. Or you need to do it in high pressure, which itself takes energy, not as much as cryogenics, but still takes energy. So all the thing you are doing to make hydrogen, to refine it, to purify it, to liquefy it, or to compress it, you are putting so much energy into it. At that point, you have wasted a lot of energy just trying to get the fuel. And I'm not even talking about the inefficiency that's going to come once you burn it in your fuel cell. And to give you a simpler idea, this is a very nice image that describes it. Now, this is a rough description of how much fuel mass versus size you need for 300-mile trip. So for 300 mile, you need roughly 33 kilogram of diesel. And in liters, how much volume it's going to take is 37 liters. So okay. Now for same range, how much hydrogen do you need? You need 6 kilogram. And everybody's like, yay! Here's the deal. It will take 170 liter. That is at if you pressurize it to around 700 bar, which is like 700 times the atmospheric pressure. So suffice to say, this is the part that people forget about hydrogen, is that weight wise, yes, your vehicle would be very light. However, the size of the tank that you need to carry that even at liquefied stage is ginormous. The aerodynamic drag from it, the sheer size and weight of it will reduce all the benefits that you're going to get. That's why we don't use hydrogen. So let's talk about alternatives. You have to understand, the more steps you induce in something, the more expensive it becomes. So it's too expensive. Why it's too expensive? It has too many conversion in this pipeline. Let's say you want to run your car on hydrogen. To give you a simpler understanding of this cross-section image that I'm showing is a Toyota fuel cell car. And as you can see, it has yellow things that you are seeing. Those are hydrogen high pressure tanks. They are not cheap. They are very expensive. They make LPG tank look cheap. And you have a battery. Why you need a battery in that? Well, fuel cell does not have instantaneous power. Basically, it's not like a internal combustion where you press the accelerator, it's going to give you more power. It takes time. There is a bit of lag. So even if you open the fuel valve, it will take few seconds. And people want instantaneous. When you want to press the accelerator, you want your car to go. It's not like, okay, it's going to take few minutes to catch up. So for this reason, they always have a battery pack to stabilize it, when you need acceleration or when you are doing regenerative braking or things like that. And suffice to say, what does an electric car have? Battery and motor. You already have it. Why not remove the things that are adding the cost? You can remove a very expensive high pressure hydrogen tanks. Boom, you saved money. And fuel cell, which are idiotically expensive. Boom, you saved money. And all you have to do in return is just make the battery pack bigger. Now you have less things. And as I already specified, it has too many conversions. As I said, if you want to run your car on hydrogen, you have to have many steps. Like you're going to collect water, spend energy on that, electrolyze it, spend electricity on that. Then you're going to refine, filter and compress hydrogen. Again, you're going to spend energy on that. Then you're going to put your hydrogen into the pressure tanks. Then that pressure tank will feed fuel cell. Then the fuel cell will drive your motors. So many steps. All you can do is simply say, okay, I will put direct electricity directly into my battery. That's it. So, and you have to understand, in earlier days, the reason why hydrogen was looked at very seriously was very simple thing. It could allow a large scale energy storage. Basically, you're going to electrolyze the water when you have surplus of electricity, and at the peak demands, you're going to combust it or send it through a jet engine or a fuel cell. Fuel cells were not, well, they are still not cheap. So to get the energy back. However, nowadays even grid scale battery packs are available, and we are all familiar with Tesla's battery pack. And this new kid in the block that we have, it's a container size battery. It's called a flow battery. They are Z cell batteries. Basically, they have liquid electrolytes that are moving, and they are changing their chemistry to give you electricity in or out. So suffice to say, the whole aspect of not using battery for grid scale was at grid scale capacity batteries are idiotically expensive. This is not. At 2, and your batteries lose power over time. However, that's true to some extent with hydrogen. Like, of course, your tank's gonna leak a little bit, but you can calculate for it. So batteries, as you hold them for a very long time, they're gonna lose power. This, however, can hold its charge for 10 years. Yes, 10 years. They even come with warranty of that, and they have no degradation of capacity. So let's say you built this as a power storage. Boom, your problem solved. So as we now see, cars make no sense. Energy storage are already better. So these are the final nail in the coffin why we don't see a hydrogen economy. I hope you liked my presentation. If you liked it, please like. If you didn't, dislike it. Leave a comment. Please subscribe. I make video every day. And as always, thanks for watching.